So, it's been another 2 weeks because, well, I forgot to account for Christmas. My bad. Luckily, though, we're running out of holidays, so hopefully I'll keep on track from here on out. Anywho, as promised, today we'll look at how I migrated my various containers from Unraid to Docker Compose. We looked at how I moved Audio Bookshelf in the past. If you missed that, and if I remember to add it, there will be a link floating around here somewhere for that, if you want to go back and check it out. That was all well and good for a single app, but not really ideal for a whole home lab worth of services. So I moved to Docker Compose. Compose file is Docker's way of structuring a deployment. It allows you to specify networks, volumes, and containers, as well as how they can and can't interact, what resources to have access to, and so on. In my case, it's relatively straightforward, just a network and a smattering of services. As a quick sidebar, if you're truly brand new to Docker, I'd encourage you to check out something like Network Chuck's Docker series before going any further. We won't get too into the weeds, but I'm also not going to cover what is Docker, because I can't possibly do it justice the way Chuck did. Again, if I remember, there'll be a link floating around. I really do encourage you to go have a look. Anyway, let's take a look at what's here. First, we'll look at the network just real quick, because it gives context to some of the other things I've got configured. Out of the box, Docker allows a fair few network options. By default, it'll expose all of your services on the host's IP and differentiate between them using different ports. While that works, I'm not a huge fan. One of the things I did like in my Unraid config is that every service had its own IP address. So to mimic that here, I went with an IPVLAN specified here, and specifically an L3 IPVLAN. This lets my host act as a router, and it makes the whole network infrastructure pretty simple. The other things to call out here are, obviously I had to name the home lab, and then this parent device is just the name of the NIC that it's actually using to communicate. You can see in my subnet and IP range config down here, I have a whole 255 IP addresses I can assign to this thing. We'll get more into this variable in just a minute. You see it's everywhere. But first, a quick sidebar. There were some complications using an L3 IPVLAN. Since the host machine acts as a router for the subnet in this configuration, I had to set up a static route to let local network traffic know where to look for these addresses. And it turns out Windows just didn't give a damn for that static route. I ended up specifying that static route in Windows' local table manually, which means I have to do that on all of my network machines, which isn't ideal. I feel like there has to be a better way to do this, but I couldn't find it before I, honestly got bored and moved on to something else. If you know how to fix this, other than telling me just to run Linux, which isn't going to fly for my kids, do please drop a comment. I'd love to figure this out. Anywho, let's talk about this net variable. This comes from the .env file. Typically, it's just .env. I name mine .env.demo so that I wouldn't have to go through the trouble of blurring passwords and other sensitive info. This is meant to let you specify, passwords and other sensitive info. I'm also using it for common values like the subnet prefix, my time zone you can see up at the top, database names, that kind of thing. So in the one we're looking at, it's this net variable, and that gets referenced over here like so. You'll see a few more of these as we go along. Now, on to what's actually configured here. You can see I broke it down very roughly by IP range. So 10 to 99 is going to be network services and security services. This is things like Adguard, Nextcloud, Vault Warden, just basic security and network stuff. After that, from 100 to 199, it's media services. This is Plex, Jellyfin, Audio Bookshelf like we configured last time, and Comga, things like that. And lastly, backend services is things like Postgres, Redis, and I think Cloudflare is in this group for some reason, even though it probably belongs in the first one. Anyway, let's dive into this. We'll look at Adguard by way of an example, because it's pretty straightforward, and then we'll look at some of the more complex ones after. First things first, your service needs a name. I'll stop double-clicking things, that's driving me crazy. Your service needs a name. After all, if you don't have a name, how can you know what you're making? I usually just use the actual name of the service. If I have multiple instances, like multiple Redis caches or something, I would suffix this with an identifier. Separate from name, container name sets how the container is referenced. This is how it shows up in things like Portainer, how you can address it from the Docker command line, so on. You can leave this blank, but I've seen it concatenate the service name from the line above with some weird boilerplate values when I do that, and I just prefer to be explicit. So in my Docker Compose file, you'll see that every service has an explicit container name. Next is the image path. If you're using a common repo like Docker.io or GitHub, more often than not, you can specify just the project name, the actual service name, and then the version. If you're using something non-standard, you may have to specify a whole path or register that repo with Docker. I'm not going to cover that here. We'll stick to just basic repos. The last thing to call out here is this :latest tag. This specifies which version of the service you want to pull down. Latest, in most cases I've seen, means latest stable build. For a service that the house relies on, this is always what I'm going to pick. Some services will offer like nightly builds, RC builds, canary builds. If you want to live on the bleeding edge, by all means, typically you run into stability concerns at that point. From here, we start to get into, at least to a point, service-dependent configuration. You can see I'm specifying a couple of volumes for Adguard here. One is just a working directory, one is a place for to dump its config. These are going to differ from service to service, but the structure is always going to be this. This is basically local storage the service has access to. And the way that's laid out is this is the local path on the left, and then on the right side of the colon is the path that maps to internal to the container. Next, we have the restart behavior. This controls what happens if the container crashes, but also what happens if the host encounters a problem. So in my case, setting this to always makes sense because it ensures that either Docker will try to spin this back up if it dies for some reason, or it'll force Docker to spin it back up if the host reboots, crashes, whatever. And then the last thing for Adguard is the network configuration. Here, just by name, we're onboarding to the home lab network and giving it the explicit IP 10. So it'll use the prefix from the environment file, 10685.10. And that's it for a super simple container. There are some others that get a little fancier. You can see Vault Warden uses a bunch of environment variables to set things like the time zone, the admin token, whether or not signups and invitations are allowed. And similarly, Nextcloud uses environment variables to link to the Redis cache that it uses for its own acceleration. Like volumes, environment variables are going to be service specific, so you'll need to find them in the service documentation for whatever you're trying to run. In my experiences, this documentation has been really solid. Like the community around this is fantastic, and you can always find samples and whatnot. Along those lines, maybe the last exciting one to look at is Plex. Configuring Plex with hardware acceleration was a bit of a bear. Now, I'm running Docker in an Ubuntu VM on Proxmox, and I'll probably do a separate video on what it took to get GPU pass through all that noise to here. But for today, let's just look at the Docker config side of things. The first interesting thing for me was this deploy block. This basically gives the service a reservation on the GPU and actually gives it priority access to the hardware. Next thing we had to set was this GPU ID. Again, I'm pulling this from my environment file, followed by the capabilities of that GPU. In my case, I just told it to go hog wild and gave it all. It'll only ever use the transcoding features. Finally, in the devices section, we point Plex to dev DRI, so it knows where to look for the desired GPU. And that's kind of it. Everything else I'm running is a variation on what we've touched on. Now, that's all well and good, but what the heck do we do with this Docker Compose file? For that, let's hop over to our Docker host and we'll look at starting and stopping services. First, I'll head to my home lab directory, which in my case is dissident/homelab. Dissident because everything I'm using for Docker is actually coming from NFS shares from my main storage server, Dissident. So there's nothing Docker needs that actually lives on this machine. I could flatten this and rebuild it and be just fine. If we do ls from here, you You can see this is where my Docker Compose file lives, as well as the config folders for all the runtime data Docker needs. If we do an ls-h, not -h, -a, you can see that the .environment file is also here. You can run Docker Compose from anywhere, but if you do it from the directory your Compose file is in, and it's named dockercompose.yaml, Docker will pick it up without you needing to specify a path. Before we fire things up, let's see what's running currently. To do that, we'll do sudo docker container ls, and you can see there's no current running container. We'll do the same thing for the network, and all we get is the boilerplate bridge, host, and none networks that come standard with Docker. So let's fire this thing up. To do that, it's sudo docker compose up -d. The -d is important. That forces Docker into daemon mode and lets it run in the background. Without that, Docker will run as a foreground process and prevent you from doing anything else. Here we go. In this case, it fired everything up right away. Typically for first runs, it would take some time to download images. I did that already, so in my case, I got to skip that step. Let's have another look at what's running. We'll start with network, and there's home lab. So that's all up and running. Let's check containers, and there are my 15 different containers. Some of them are still starting. That's totally normal. Some of these take quite a bit, but for the majority, they're up and running and healthy. About the only other interesting thing we're going to cover is shutting things down. So we'll do sudo docker compose down, and pretty immediately it shuts everything down. And we can check again to make sure everything got cleaned up. Home lab network is gone, and all the containers are gone. But that's enough of that. I gotta fire this back up before the kids complain about Plex being missing. Turn it back on, everything fires back up immediately. And that's that. We've looked at the basics of Docker Compose, we walked through a couple more complex examples, and we covered starting and stopping services. To get started, that's really all you need. If you haven't already, I really do encourage you to give running Docker yourself a try. For me, coming from Unraid, where all this stuff is abstracted away, like launching it or configuring it all myself was pretty intimidating, but Docker Compose makes it really easy. That's going to do it for today. As usual, I'm not sure what next Monday is going to bring. I might dive into GPU Passthrough for Plex, but I also have some new hardware on the way. If that gets here in time, we might do something else entirely. Thanks for coming along, and I'll see you next week.